In today's class, we're going to discuss the advanced encryption standards and public key encryption protocols and RSA algorithms. So in 1990s, so the US government wanted to standardize the cryptography uh, algorithms, which is universally used by them. It is called as advanced encryption algorithms. So that has been invented. So here it is a better security algorithm, strength compared to data encryption standards. If it is what is the weakness of that is a data encryption standards they have taken into, so that the it has been taken into consideration here. It is a Rigendal in 1991 in the US government. It is exactly, so it is developed this algorithm. So that is the advanced encryption standards. Here, so it is a security. What is the weaker in the weaker sections has been found out by the Rigendal. So in data encryption standard, it is a plain text of 64-bit. They are taken in the case of data encryption standards. So that is the 64-bit plain text easily can hackers can access this kind of plain text can be able to ciphertext can be easily guess. It is easily detect. So with some cryptography techniques. So it is that is the one of the weakness, and also the key size is so it is where it is a data encryption standard 56 bit of key they're using. Here instead of 56 bit the hackers can easily access. So if it is a key size is increases, the cryptography strength is also increases. That is a Rigendal. It is a, so found that it is a key size has been used in the Rigendal. So in the advanced encryption standards is a 128 bit. Even message size is also increased into 128 bit of blocks. Even key size is a 128 bit and 191 bit and also 56 bit is tried, and the number of rounds is taken. So instead of 16 rounds is reduced the rounds into 10 to 14 rounds. So that is a 10 rounds up to 14 rounds is tried, and his plain text is formed with a 16 byte of so M not through, so M15 it is fed into around one after initialization stage. It is a byte substitution will be taken place as the first step, and in the second step it is a, so substitute the units. So it is exactly that is a first step. It is substitute the unit. So perform the byte by byte substitution of the particular blocks. So then the cipher will be get back in the so particular byte to byte substitution of the blocks has been taken out of the first step, and the cipher is moved through the permutation stage, shifting of the, so the stage and shift the rows in, so shift the rows. So that is exactly the second steps, shift the rows, and so to the, so mix the columns in the third state. At the end of this round, so round of the key, so all 16 bits of ciphers it is exclusive or with the, so that is 16 bits bytes of round of one key k1 and through another case up to, so k15th rounded exactly it is a follow. So that is a so it is a step. There are only four step procedures. It is a byte substitution is the first step, and so shifting of rows it is the second step, and shifting of and mix the columns in the third step, and round the key additions, and round the key addition and do the exclusive or the 16 byte of rounded keys of K0 to K15 it will follow. So advanced encryption by Regenda. So here that is a, so entire step has been explained here. That is initialization M1 to, so that is exactly M1, so M0 to M15. So that is a plain text length. It is a 128 bit they have taken it. Okay. So it is a, exactly, so that is a plain text. It is a message size is 128 bit of blocks. So that is exactly S box they are followed here. Shifting this is S box. So the first stage, then it is do the permutations and mix the, so that is a rows, and shift the columns, so mix the rows, and so it is exactly rows should be do some shuffling here done, and mixing of the columns. So whatever the columns of mixing years, do the exclusive OR operation with the certain keys, key K1 to K15. So each time that is a round, that is a ciphertext will be get back C0 to C15. So that is a one round. Similar rounds are followed up to, so it is a, so 10th round. It is exactly to the substitution, and so initial byte substitution, byte by byte substitution, shift the rows and mix the columns, and it is a do the, so shift the rows. These are permutations. So exactly it is a shuffling of so that is a shifting of rows. That is done, and the permutations, it is mix the columns, and finally it is exclusive or with the keys, and it is finally so strong ciphertext will be get back. So this is exactly key expansion will be also performed, that is an encryption process. Similarly, the reverse process is also called as a decryption process. Exactly, it is followed. So here it is a public key cryptography protocols. This is also called as symmetric key, asymmetric R2 key encryption. So it is a public key cryptography. So it is a, so whatever I explained so far, advanced encryption, it is a symmetric key. So same key has been used at the sender. So while doing encryption and doing decryption, also same key, but it is a cryptography as the weakness in the data encryption standard. So it is a cryptography strength has to be increased with the increasing the, so that is a bit blocks, 128 bit blocks. So that is a blocks, and it is so byte by byte substitution will take place, and that is exactly it is done in the advanced encryption symmetric key algorithms. So in public key encryption protocols, that is it is also called as asymmetric R2 encryption. One is private and public key they use at the sender side. So and even receiver side pair of keys, private and public keys they are using. So the sender and receivers pair of keys like private and public different keys they are using. So this is based on the mathematical functions rather than the substitution or permutations may not be used here. So that is the two popular protocols of public key protocols. One is RSA, that is Arabist, Schomer, Edelman. It is invented. The protocol, it is also called as an algorithm. It is a very popular algorithm. It is RSA protocol or algorithm. So one more popular protocol, it is a Diffie-Hellman. It is just a key exchange, how key securely exchange. So between so two users, user one and user two. So that is Diffie-Hellman is invented this key exchange. It is not a public key or private. So that is a encryption and decryption algorithm. It is a key exchange algorithm. So either of these two related keys can be how it is used for encryption, and other one for decryption. How two related keys. So two related keys how exactly used for. So it is a encryption. So normally it is a private key and public key pair they are using. So for encryption, even in decryption. So each system so publishes the encryption key and placing it. So normally, so that is each system means in each the communicating parties must be register their public keys in the key. So that is a distribution center. It is also called as public register center, and sort out this key as a public one. So it can place as a key as a public key like. So as and when required, and the sender will take the receiver public key, and receiver will take the key of receiver will take the sender key. So from the public register center, or it is also called as key distribution center. It is publicly available. So this is securely exchanging the keys. So it is taken the key from the key distribution center again. So it is a companion key is kept as a private here. So suppose the user A wishes to send a message to the user B. So user A encrypt the message by using a B public key available. So in the public register center, it is also called as key distribution center. So it is again it is requesting the key distribution center securely. So get the key from the key distribution center to the requested parties. So here at the receiver end also, so B decrypt the messages so using the private key. So because it is a public key, so public key using. So that is sender A when is sending the messages, B public key can be used, and that is encrypt the messages. B taken by the user A, B public key has been taken by the that is a receiver user B. So user A as and when sending the messages, user B will take that is A's public key, opposite person public key securely from the key distribution center. So it is a pair of keys got, and kept his private key as a securely. So both the parties have kept their private key secure, and use the whatever the opposite person used encryption public key will be taken by that is receiver will got the public key of opposite person. So there is definitely it is using this pair of keys, public key and private key pair. So it is decrypting the ciphertext into plain text that is possible. No other recipient can decrypt the particular messages since only the user B knows its private key. So that is the reason. So that is always it is a user A. It is a private key cannot be shared. So it is already it is a privately secure. So their public key must be it is a shared, and it is already it is registered in the public register center. It is also called as key distribution center. So where it is a keys are so it is securely maintained by these key distribution center. So every communicating entity must be registered first. Their public must be shared their public key in the key distribution center. So user A take the user B public key while so encrypting the messages. Always user B public key they're used by the user A, and user B while sending messages user A public key so use and send the so encrypt the messages and send to the so that is a user A. So as and when receive the ciphertext user A, so that is a so user A takes the B public key from the key distribution center, and a pair of keys is got so is private key and public key is taken from the so it is a key distribution center. So definitely decrypt the messages that is possible. So the public key system is a more powerful than secret key system. It is a symmetric key system. It is a so secret. It is also called a secret key system. It is a public key system. It is a pair of key using. So it is a one is a private and public keys. So there is a more powerful and provides the better security and message privacy. And drawback of these public key system. It is a slow speed and more complex computationally. So and computationally it is a more complex. So next is we can discuss about. So that is RSA, one of the public key cryptography algorithm. So it is invented by Sir Ramesh Sharma and Adelman. These are the three scientists invented so algorithm. It is a pair of key. So one is a public key and private keys. Normally they are using in this algorithm. Assume that the plain text M must be encrypted to the ciphertext C. This is the algorithm follows the three phases. One is a key generation phase and encryption phase and decryption phase. So in the key generation algorithm, there are two prime numbers, so, or it is two prime numbers they are taken. One is A and B. So that is a compute the so multiplication of these two prime numbers they are stored in N. So again it is a select the encryption key before selecting encryption key. So that is a so they do some computation. So A minus one, it is a B minus one. So it is a pi of N. It is a relatively prime numbers pi of M. It is a taken and find the X encryption key. So that is a X and find so that is a Y and calculate the decryption key. That is the encryption key is X and calculate the decryption key with the following the equation X into Y. So mod of A minus one and B minus one that should be in that should be one. So it is at this point A and B are discarded. The public key pair so has to be collected X comma N. N is already computed with the so A into B and the private key pair so Y and then they have to so we can able to select. So here so the encryption algorithm both sender and receiver must know the value of N. So only so the value will be known by each others the whatever the computations has been done. The sender knows the value of X. So the sender so that is a user A, it is a sender, assume that so only know the value of X and so that is a user B, so that is a receiver, so only receiver know the value of Y. So here ciphertext C is constructed. C is equal to M to the power of X mod N, and that is so the encryption algorithm. So using this equation, C is the ciphertext, M is the messages to be so devised by whatever the so the value of X and mod N, and decryption algorithm given ciphertext C, the plain text M. So it is extracted by so M is equal to reverse process. M is equal to ciphertext so to the power of Y mod N. So using this equation, decrypt the so algorithm decryption algorithms we can perform. So in this class we have discussed about so advanced encryption standards and so what is the algorithms and what is the working so that is encryption and decryption process of advanced encryption standards and public encryption key protocols. There are two protocols. One is the RSA protocol and DPL exchange algorithms, exchange of protocols we have learned, and the RSA algorithms in detail we have studied. So that's all about this class.